Hi, welcome to lesson 5 for redox reactions. This is just to get you ready to be able to do one of the assessments, and this showing the format and what you're going to be expected to do in a little bit more detail than the last lesson. So you are going to be given this table in the assessment, and what you need to be able to do is to read the question in the assessment, and using that information figure out what ion you want to start with, and then pick from this list of possible ions what you're going to finish with as well. Here's some things that you need to remember when you're trying to pick which ions you're going to worry about and write equations for. Firstly, you must ignore sodium and potassium and nitrate. You ignore them because they're always just spectators in the reaction. They don't do any oxidation or reduction, so we can just immediately write them off. Whenever iron, whether it's iron 2 plus or iron 3 plus, is present, so 2 plus is this one, and Fe 3 plus is the one where you've got a Roman number 3. Whenever they're present in a compound, it's the ion that you want to pick, and whatever it's combined with, like the sulfate, you want to ignore. Okay, we don't want to see sulfate in that reaction, we just want to worry about the ion. With hydrogen peroxide, which is H2O2, this is a tricky one because it's able to be oxidized and reduced. When it's oxidized, it forms oxygen. When it's reduced, it forms H2O. So you have to be very careful to read the question. If it's bubbling gas, which one do you think it must have formed, oxygen or water? That's right, if it's bubbling gas, that means it must be going to oxygen. And when there's no gas, it will be going to the water. Okay, so be careful when you read the observations in the question so that you know what peroxide is going to go to. So when you're recording your observations, you are going to, in each of the parts of the table, going to say what you see for each ion. Like you might see purple going to colourless, or a gas forming, or you might see no change when something just goes from a colourless ion to another colourless ion. Okay, I'm showing you now how this works. Always in the assessments that we've got, the first question is going to be a metal plus acid question. Metal plus acid makes salt and hydrogen, if you'll remember that from year 11. So this first question, whenever you've got an acid, it might be hydrochloric, sulfuric, nitric, whatever the acid is, we're not worried about the chloric part of it. We're just worried about the H plus that all acids have. And if you look down this list, what could H plus possibly turn into? The only thing it could turn into is this one here. It's the only one that's got hydrogen on its own. Okay, so our first half reaction is going to start with these two species. So we've got H plus and H2, and going down the list you'll see H plus is a colourless ion, so you're going to write that, and H2 is a colourless gas, so you're going to write that down. Okay, don't use initials like I have, write it down. And what you will see, you won't see a colourless ion, but you will see a gas produced. So here you'll write bubbles of gas. Okay, the other thing you will see is a grey metal, the zinc, and you'll again look down this list. It's been cut off the bottom, but you would see on this list Zn2+. That's the only thing it could possibly have turned into. We've started with this zinc, the atom, and on the list you'll find the ion that it must turn into to form that salt. So this half reaction is going to have zinc going to Zn2+. And here you're going to say grey solid disappears, and here you're going to say the Zn is the grey solid, and you're going to find from the table that this is a colourless ion, and that's what you're going to write there. Okay, now I'm not going to go into it now because it was in the previous lesson, but you're going to be expected to now do your half equations where you balance everything and add electrons to the appropriate side. Okay, so you would do that, and when you've done that, that's getting it up to a merit level, and when you add the whole thing to make a whole equation here, and putting a rectangle around the reductant and a circle around the oxidant down here, that gets you up to your excellence. Okay, so the next question's got acidified potassium dichromate. Now what did I tell you to do with potassium? You ignore it. So you're looking for dichromate on the list. So going down the list, here's dichromate. So you know you've got this ion here. So you're going to write, I would start here, write down the ion that you've started with. Make sure you get the charges off the chart correctly, because they are important with your balancing. Now you've got to look down this list to see what could dichromate possibly turn into. It's got chromium in it. Look at the element that's not oxygen and hydrogen with these tricky ones. What isn't oxygen, what isn't hydrogen is chromium. So down this list looking for what is there that hasn't got chromium in it, has got chromium in it. The only choice on the list is Cr3+. So that is your first half reaction. So you're going to start with the dichromate, and you're going to finish with the Cr3+. And then you're going to go and do your 4-step balancing system with that. You're going to explain what you would see with dichromate. Dichromate's orange. You're going to see that Cr3+ is green. So your observation would be orange to green there. Now what was it added to? It was added to iron 2 sulfate. Now remember I told you when you've got iron 2 or iron 3, you ignore whatever it's with. So we're not worried about the sulfate, we're just going to worry about the Fe. So looking down the list, we find Fe2+, and looking down the list, what could it possibly turn into? The only other thing with Fe in there is Fe3+, so that must be what it turns into. So Fe2+ goes to Fe3+. Okay, then you're going to say what colour they are here, and describe the observation here. Okay, next slide. Here we've got potassium permanganate to start with. What are we ignoring? That's right, we ignore the potassium. We find permanganate on the list, and its formula is MnO4 minus. And what could it possibly turn into? Well, we're going to look for something that's got Mn in it. And the only one that's got Mn in it is the manganese ion, so that must be what it turns into. It's added to potassium iodide. What are we ignoring? Potassium. So we look for iodide on our list. Here it is, I minus. What could it possibly turn into? The only thing with iodine on the list is I2. So that's what our second equation is going to have. Okay, you're going to write the colour. This is purple. This is colourless iron. This is the colourless iron. This is brown. So your observation is going to be purple goes colourless and brown forms. Okay. Now I'm just going to run through again how to do the half equation balancing and the formation of a whole equation. It would normally be done up here and here, but because of this pink table in the way, I'm going to do it down the bottom here. So we'll have MnO4 minus, we know goes to Mn2 plus. Step 1, you balance what isn't hydrogen and oxygen. So in this case it's manganese. There's one there and there's one there. I don't need to do anything. Step 2, I have to add water to balance the oxygens. So I've got 4 oxygens here, so I need to add 4 waters to the other side. So that now I've got 4 oxygens here. Step 3, tree, you've got a picture of a tree with hydrogen ions in it because you're adding hydrogen ions now to balance hydrogens. So on this side I've got 4 times 2 making 8 hydrogens, so I need 8 hydrogen ions on this side. Now step 4 is I'm going to add electrons to the most positive side. Now when I add up the charges on the right here, I've got 2 plus. On the left I have 8 hydrogen ions, so that's 8 plus minus 1 for the permanganate ions. So overall on this side I've got 7 plus. So I've got 7 pluses on the left and 2 pluses on the right. I have to add electrons to the most positive side, which is the 7 side, and I have to add enough negative electrons to make it equal the 2 plus on the other side. So therefore I've got to write 5 electrons. Alright, so that's my number 1 half reaction. My number 2 half reaction is the iodide one. So I'm going from I minus to I2. Now because there's 2 iodines on this side and only 1 on this side, I'm going to have to put a 2 there. Now the most positive side here is this right side because there's no charge. Here I've got 2 minuses for the iodides. So I have to add 2 electrons to this side, so I've got 2 minuses on both sides. Okay, now before I can add the 2 half equations together, remember you have to have the same number of electrons on both sides. I've got 2 on this side and 5 on that side. So that means I have to multiply them both up to get 10 in order to cancel the electrons out. So I'm going to times this one by 2 and this one by 5. So that will make 10 electrons. So I have to go through and make this 2 of that, cross out that, make that 16. So I'm doubling everything, crossing this out, making 10, adding a 2 there, crossing this out and making 8. So the second one I'm multiplying everything by 5, so I have to cross this out and make it 10. Put 5 in front of that, and crossing that out and making 10. Okay, now before I add it together, cross out the electrons because they're the same on both sides. So my whole equation is everything on the left, so 2 MnO4s plus 16 H pluses plus 10 I minuses, and then everything on the right, 2 Mn 2 pluses plus 8 H2Os plus 5 I2s. Okay, then I'm going to circle the oxidant and put a rectangle around the reductant, and the rule here is the 3R rule. Electrons on right is the reductant, and that gets the rectangle. So this half equation, this second one, is the half equation with the electrons on the right. So it is the I minus that gets the rectangle. And here the electrons are on the left for the first reaction, so this is the permanganate is the one that gets the circle. And then down here you're going to say the MnO4 is the oxidant because of it gained electrons and was reduced. Sorry, we're using this term RIG, reduction is gain, and you're going to say that the I minus is the reductant because it lost electrons and was oxidized. So we've got reductant with oil, redant and oil, oxidant and RIG. Okay, hopefully that makes sense.